All right, here we are. Like I mentioned in my email, all that remains to be done is to wrap up this sample final, and then we'll be completely done with all the new content. So then what remains is if you look at Cengage, heading down to the wire, um, let's open this up for a second. All right, so where are we? Here we go. So let's just take a quick look at the schedule. Now, of course, chapter 14 is our discussion about regression analysis and that we just finished up last week. And then over the weekend, I did make a new video, which you'll see in YouTube. And that is where I covered the sample midterm number 2. And so now, let's take a look at our schedule. This coming Sunday is August the 2nd. And so you'll need to have the chapter 14 assignment done. And then I hope you haven't waited to the last minute, but all three of these, I put them as late as I could so that the grades get done in time. And so I see a lot of people have already done these, which is great. And not only that, but look at those scores. This is fantastic. So, but just be aware that now the third is a Monday. Okay, Sunday is the second. So you might want to do this one first and then wrap these up. So if you have something seriously wrong, like, oh, I don't know, your boss sends you to a new state to work in all of a sudden, or you've got a vacation you've been planning for months, or something along those lines, it's still possible to arrange for an incomplete grade, I think. I'd have to look into that. I'm not sure how late. Usually you have right until the last minute to ask for an incomplete in any course during the normal school year. So, but that's usually reserved for really, really serious cases where there's something that's going to make it impossible for you to finish everything on time. But if it does happen, you can let me know and we'll figure it out. But other than that, just, try not to, let the deadline slip by and have everything done by Monday night, and then you'll get your grade. Now, in the short run, there's going to come a day when the grade book opens up and I can submit all your grades to the school. But I don't know what day that is. If sometimes it's very early, sometimes it's not. So if anyone has a reason why they desperately need to have their grade immediately, or they just want to know, you can just send me an email if you don't see it in your account. I don't know how long that part of it takes. Once I put them in, that's it. I don't see anything else. So, but I know that some people are anxious to know how they did, and so that's okay. You can send me an email, and as soon as I have your grade ready, I'll just let you know what it was. Um, I don't think there's anyone in this class who needs a transcript for like another school, let's say. Sometimes during the summer you get visitors. I don't think there's anyone in that category here, but I might be wrong. I don't know. So, but if you are from another school, then you should let me know so I can, make sure you get your transcripts in time. But anyway, other than that, we're just going to wrap up this sample final, and then we'll be done. But you can always request a Zoom session if you're stuck with something, um, that kind of thing, or else just send me emails. And so I'll be available. I'll be keeping my eyes open for emails or requests for Zoom sessions. But the way the numbers are looking here, I don't think anyone's going to need help. Look at this. These grades are wonderful. Okay. All right. Anyway, so the other thing too, I guess as a Fordham student, I guess you always have access to this Blackboard account. I don't think it'll like actually closed down or anything. So if you want to save these materials, the notes, for example, or the videos, well, the videos are on YouTube, so you can see them forever. But the actual notes that we put together during the course and the Excel examples, if you want to keep those, you probably should download them, but at the end of the course, although like I said, I believe you'll still continue to have access to this as long as you're at Fordham. But if you somehow are unable to do that, I can send you another copy if you ask for it. Okay. So just in case you say, oh my God, I really needed those Excel spreadsheets and I forgot to download them, that's all right. I can find them for you. All right, so let's open this thing up. Now, this one seems to have a lot of fill-ins. There's something about this subject matter that lends itself well to fill-ins. So what I did was I reopened the answers to Armand's from last time. I think it'll be easier to explain all of this in terms of this printout rather than trying to go through all the equations and stuff. So let's see how this goes. All right, here we go. So um, we'll start with the equation of the population regression line. And all right, so remember that's the one where we're using Greek letters. Because this is a population measure, we're going to use Greek letters. And so if you remember how this works, it's beta 0, which is our intercept, plus beta 1x, and don't forget the error term. All right, this is something that's not normally associated with a linear equation, but here we do need that error term. Okay, and again, if you're not sure which is which, remember the Greek letters are used for population measures, and Roman letters, or our alphabet, is used for sample measures. Okay, so what's next? Let's, I don't think I've ever heard that before. All right, it doesn't look like anyone's trying to answer a question, so all right, let's go on. There it is again. What was that? I don't know. All right, let's. Okay, so now we want to know the equation of the sample regression line. It's not cooperating with me here. All right, so the corresponding formula for the sample regression line is this one. So we replace the betas with b's because, again, we use the Roman alphabet for sample measures. The little pointy thing here, the y hat, means that this is an estimated value as opposed to the actual population regression line. Okay, what is the range of possible values for the correlation coefficient? Oh, sorry, the coefficient of determination. Now, you might recall that this number, or this is sometimes written as r squared, capital R squared. Sometimes it's r squared, lowercase. That depends on what book you're using. Sometimes maybe Excel will have somewhat different notation than a book, but they're both the same thing. Just be aware of that. They both mean the coefficient of determination. And if you remember, this is bounded between 0 and 1. Okay. And you also remember that the closer it is to 1, the better our regression equation fits the data that we have. So just as a quick example of that, I'll draw a couple of diagrams here that show you two cases, one with a very low r squared and one with a very high r squared. If the points are awfully, awfully close to that line, then r will be close to 1, which means that this regression equation is actually doing a very good job explaining this relationship. But if it's loosely scattered all over that line, that indicates that this is not a terribly strong relationship and that we might want to think about choosing another regression line. numbers, maybe pick two different, a different X to explain why, but that's why that number is there to help us determine the quality of this fit of this regression line to the data. An error term. Now, actually, I want to get these both at once because one of these refers to the population regression line and the other is the sample. Now, here the book is using epsilon for the error term, and it's the actual y minus um, predicted y. And when we say predicted, they mean by the regression line. And, when we drew this picture, if you remember, you could visualize it as something like this. Here's your x, um, estimated or predicted y from the regression line. But the actual y, let's say, was way up here. So the vertical distance between these two is our error term. And so let's say this is x1, that means this is epsilon 1. Now, the residual is the exact same idea, except that it applies to the sample regression line rather than the population. So most books use the letter E for that. I didn't particularly see that in the slides, but because if you know epsilon is the Greek E, this is also actual y minus predicted y, the difference being that the predicted y is coming from the sample regression line. That's the only way in which they're different from each other. Okay. Sometimes, well, all right, that I think that's good enough. 7, variation. I'm not positive that we specifically went over this last time. If you remember, we had these terms, sums of squares. There's a bunch of sums of squares that we were looking at. And if you go back to Armand's, you'll remember there's 3 of them. And I labeled these because I wanted to make it crystal clear which is which. The Excel doesn't really label them maybe as clearly as it could. So in this ANOVA table, we have the regression sum of squares. We have the residual, or sometimes called error sum of squares, and then total sum of squares on the bottom. It has another name, and that name is variation. So let's add that to our list here. It's the distance between each actual y and that y bar. Okay, so notice here's our regression line. Sometimes there's a subscript I, sometimes there isn't. It depends on the book. But if there's some y, and then there's going to be a mean y in here somewhere. So let's say this is our y, this is our x, x1, y1. What they're getting at here is you're looking at the distances between these y's and the y bar, and then you're squaring them. So this is the equivalent of SST. It means the same thing. So don't be confused. They are the same concept. I don't know why it needs multiple names, but it just, that's what it's called. Okay, now, what is one of the assumptions? All right, now this one, we could go on for a while here. There's quite a few, but it's only asking for one. So probably the ones you want to remember are these. There is a linear relationship between X and Y that's understood. I mean, that's why it's called linear regression analysis. The error terms are random variables with a mean of zero and a fixed um, variance. Actually, we'll call it standard deviation, which is just going to be designated with the Greek letter sigma. Sigma in here. Maybe not. I know it's in here somewhere. Oh, here we go. Um, there it is. Okay. So in other words, we don't know what that number is, but we do know or assume that it's the same for every X in our data set. Hmm. Then we assume that the error terms are independent of each other. Okay. Now, of course, if those assumptions fail to be met, then the results will be less accurate than they should be. But we can still usually get reasonably good results unless these assumptions are grossly violated. And even then, there are ways we can correct for them. Okay. So, all right. Anyway, number 9, MSC. Now, what is that all about? Let's go back and look at Armand's for a second. So, if you look at your Armand's results, those are here. Looks like I did not label those. I probably should have. This would be defined as MSR. M stands for mean. Okay. This would be MSE. And so what they've done is they've taken whatever the degrees of freedom are, gives us MSR. In this case, it's the same because they're one. But MSE is equal to SSE, the sum of the squared errors, divided by its degrees of freedom, which is 8. Oh, wait, sorry, I wrote it wrong. It's SSE divided by 8 would be MSE. But in general, you're supposed to write it like this. The most general way of writing it is SSE over n minus 2. Okay, where n, of course, is the sample size. So in other words, the squares, the sums, we have sums of squares in this column C. The mean squares are the sums divided by the degrees of freedom. That's where they're coming from. Okay, so, and then of course you can see the F statistic is the ratio of these two. And then here, this is actually the p-value associated with the F statistic. All right, what else do we have here? How is the standard? Okay, we mentioned this one too. It is on the Excel spreadsheet. Now, standard error of the estimate is often abbreviated S. Oh, that's easy. So if you look at Armand's, you'll see that the MSE is 191.25. The square root is right here. 13.8293. So we can confirm that right now. You take the square root of 191.25. It's 13.829. Okay. But what does that standard error refer to? So this is the estimated common standard deviation of the error terms. Okay, remember we assumed that it was a constant. Well, this is our best estimate of what that number actually is. Right? Remember up here, we said that we have a fixed standard deviation. This is our best estimate of it. Okay. Now, why does this matter? Well, it shows up in several of the formulas, including these, the confidence intervals. Also, if this number is very large, it tends to indicate that the regression model we have may not be doing a great job of explaining the relationship between X and Y. It's a cause for concern. Let's put it that way. Okay. All right. 11. The difference between simple and multiple regression is very simple. Okay. Simple regression, one independent variable, which means X. With multiple regression, we have two or more independent variables. Now, this chapter only covered simple regression. Multiple is found in chapter 15. If you're dying to know how that works, you can go ahead and read it. But you'll discover pretty quickly that unfortunately, having two or more x's does make everything quite a bit more complicated. If we're going to go through there, you better mean it, okay? Because it is a lot messier than what we were doing. But a lot of regression analysis, a lot of real world research projects do require multiple regressions. So if you're heading in that direction, you might want to at least read through it. 12, the expected value of the error terms. Now remember, one of our key assumptions is that the expected value or average of the error terms is 0. In fact, it's mentioned up here in these assumptions we were just looking at. There it is, a mean of 0. So remember, expected value and mean are the same concept. Okay. It just means that they offset each other. There's positive errors, there's negative. On average, they're equal to 0. 13, when testing hypotheses about the coefficient beta 1, the null, all right, let me show them both to you. This is always done the same way. It's always a two-tailed test. So if we fail to reject this null, although it doesn't ask about this, if we fail to reject the null, then there is no relationship between X and Y. Regression results are meaningless. Okay. In other words, we're assuming something that's not there. Okay. All right. 14. What is the assumed relationship between the error terms when they're independent of each other? Now, if they're not, well, then we have issues on our hands that we have to deal with. Okay. We don't know how to do that yet. That if you kept going with this material into a new, let's say, more advanced stats class, then this would come up next. But right now, we don't know how to do this. When testing the hypotheses about beta 1, the critical value is how many degrees of freedom. Now remember here, that's always going to be the t statistic. If you notice, we never actually used the standard normal for our test statistic. When you're doing regression analysis, you only use t. Okay, the F is for multiple regression. For simple regression, only T. So if you remember, well, the test statistic was this, but the critical value E alpha over 2, n minus 2 degrees of freedom. Okay, so the actual answer to this question is actually just n minus 2. Okay, it's one of those things you just have to memorize. 16, MSR. All right, well, we just went through this with the MSE. If you go back to Armand's, you'll see that MSR is equal to, oh, that's right. Um, this is the one that where the degrees of freedom is 1. Uh, that's right. So these two numbers are equal to each other with simple regression. So you can think of it as SSR over 1 if you want, but they're the same thing. Or you could just write it like this. Okay, now, of course, these questions refer specifically to simple regression analysis. In multiple regression, obviously not. All right, the error terms are consumed to follow. Oh, you know what? Hold on one second. When I wrote these assumptions up here, I think I may have left that one out. Oh my God, how could I do that? I just noticed that now. Sorry about that. The error terms are normally distributed. That's right. That's awfully important too. They're not just random variables, any random variables. They're normal with a mean of 0, a standard deviation of sigma that are independent of each other. Okay. In fact, that is probably the most important assumption. So let's do this. Yeah, that's kind of a big deal. So therefore, the answer here is um, the normal distribution. Okay. 18, what assumption is being made about the variances of those error terms? Well, whatever assumption we made about the standard deviations is the same assumption we're making about the variances, and that would be that they are all equal. All the same number. Whatever that number is, they're all the same. Now this is an interesting question. The sample regression line is estimated by minimizing what value? And that's going to be this term, which also has a name and also can be described in English as the sum of the squared residuals. So all of those would be acceptable. Okay, 20. Now this one, I guess we went over this. Yeah, we did. Simple regression, the relationship between the coefficient of determination and the correlation coefficient. In other words, if you took the square root of R squared, you'd have the right number, but not necessarily the right sign. Um, it has to have the same sign as B1, the slope coefficient. But other than that, you're basically just taking the square root. Twenty-one SSR, how's that calculated? So it looks like we're just going to I'll do these all at once. And again, we did this in Excel with our Armand's example. And so it may not be obvious where they came from, but um, here's what these are all about. So let me just give myself some more room here. That's SSR. Here's SSE and SST is that last one, which we already discussed earlier. This is also known as variation. All right, yeah, if you go back here, it's okay. But here you've got another, oh, here we go. Um, you can also calculate this though as the sum of SSR plus SSC, because that's what's happening here. You're just adding them up. So there's just a few more here. There's a lot. With a, oh, that's right. I forgot. This document is meant to cover both chapters 13 and 14. No wonder. I was like, what happened here? There's an ANOVA question. That's right. That's right. The final is not, it may seem like it, but the final is not 100% based on regression analysis. We do have to get a few ANOVAs in there too. All right. So, something like this, I'll tell you, let's open up chapter 13. There might be a table in here somewhere that illustrates this. Yeah, let's do that. Okay, here we go. This is what I was hoping. In fact, I'm going to steal this whole thing and put it in our answers. So SSTR, well, clearly then the answer is K minus 1 right there. About 25. Um, SSE would be NT is K. NT is the total of all the columns. K is the number of columns. Then 26, SST, as you can see, is NT minus 1. And then finally 27. Now, this is the equality of three proportions. Oh, no, I'm sorry, means, because that's the ANOVA. Okay, not proportions, means. In fact, it's this problem that we're trying to implement with ANOVA. So if you remember, the test statistic was based on the F distribution, which in turn is MSTR over MSE. If you're not sure, you can look at this chart again. It's right there. Okay. All right. Wonderful. In fact, that's the reason why the chart is set up this way, so that the last step is to calculate the F statistic. All right. Now we're ready for some problems. So here's what we're going to do. We could copy, with this class, we can copy it into Excel. The other option, let me just mention this. If we are using the TI-84, enter the returns to Microsoft into list one and the returns to the S&P 500 into L2. And then what you would do, and I don't think we've done this yet. We were using Excel last time, but just in case you're wondering, the Excel calculator can do this too. Here's what you have to do though. You go to Stat, um, Tests. The one you want is reg T test. And run it, it'll just ask you where you want, where did you put your information in the lists? Let's just assume that well, actually, in this case, you would have to put L2 for the X, and X and Y list would be L1. And then there's this very weird option down here. It's all these weird symbols. I want to make sure it's on does not equal 0. And then you can skip over frequency and reg EQ, skip over, or just leave it at 1. And then you've got this thing reg EQ. You can just ignore it. And you'll have your answers. Okay. Oh, okay. Well, I don't have the data on my list, so I can't go any further. But I think in interest of time, instead, we'll just copy this directly into Excel. We don't actually need these years. I'll just copy these. Now it should let me paste it in there. You know, there we go. There we go. So if you remember how this works, you're going to select these. Oh, you know what? Those are separate rows. So let's just choose these. I did that. I think it's just because they get copied out of the table. I don't feel comfortable here. I'm going to do this. I think it might goof it up a bit. So I'm going to just manually type these in here and delete this row one. There you go. It should work now. Um, Data analysis tool pack. It would be, and you can keep the header as long as you tell it that by type or clicking on labels. By the way, this time, why don't we do something we didn't do last time? We'll ask for the residual plot. It doesn't look like much of anything. They're not terribly well drawn, but yeah, you might be curious to see what they look like. Yeah, I think that's a very concerning residual plot, but that's just me. Okay. Um, anyway, so here are the results. And so what do they want to know? All right, so I'm going to copy the results now. And we can interpret them. Oops. Yeah, don't copy it directly. Um, Paste special pictures. There you go. Now that's what we like. So the regression equation is right here. Now we don't need every single one of those digits. So this is, of course, the intercept. Also have the slope. Now the intercept, the value of y when x equals 0. So in this example, this is the returns to Microsoft when the returns to the S&P 500 are zero. So if the S&P 500 has a zero return, Microsoft is going to be about 1.197%. The slope tells me that for every 1% increase in the S&P 500, there will be a 0.697368% increase in Microsoft. But it also cuts both ways. If there's a 1% decrease, then Microsoft drops by that amount. So I'll express that as and vice versa. Okay. As you can imagine, it's the slope that we're really interested in. Now, the standard error of the estimate is this number here. You see, it even says standard error. And we don't need all those digits. 0.0166, that will do very nicely. Okay. All right. Now the predict the returns. What that means is take the equation and plug in 1% for the slope. So they're saying, well, what if the S&P is 1%? What does that turn out to be? It's about 0.0189, about 1.89%. Okay. The coefficient of determination is found here, although it doesn't say that. It says R square. You notice they're using capital R. It's the same thing, capital or it doesn't matter. It's about 0.9095, let's say. The correlation, all right, now here we go. The sign of B1 is positive. So therefore, the correlation coefficient positive square root of 0.9095, which is in turn, it's approximately 0.9537. But we didn't need to even do that because it's right here. It's very strangely labeled, but this is our the correlation coefficient. All right. Okay. Test the hypothesis that beta 1 equals 0. So as it turns out, now you're going to ask for alpha is 0.05. We can directly look up the p-value in the printout, and that's going to be right here. Oh, 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 24. Okay. P is less than alpha. We reject the null and we accept the alternative. And this is always good news because what this means is that there is what we call a statistically significant relationship between X and Y. Without this, we have nothing. Okay. It means that whatever regression results we obtain, we can have some confidence in them. All right. I think that was the end of that. Oh, now this one is different because they're actually giving us the printout. Look at that. Um, just a question of figuring out what's what, which can not isn't necessarily difficult, but you're essentially just looking for everything you need on that printout. I kind of like this. All right, so we can essentially read everything we need. Oh, I see. I just realized what happened here. I left those blank on purpose. So, like for example, this test statistic here. Oh, I don't have to do any of these in MindTap, but it's kind of fun to try this. So this T statistic, that's why we're not just looking stuff up. You're taking the ratio of this term to this term. Yeah, this is a lot more useful when you're doing this in the classroom. It seems kind of silly when we're doing it with all this information in front of us. It's approximately 10.27. What's the critical value when testing the hypotheses that beta 1 equals 0? All right, well, I guess we have to look that one up. By the way, the sample size is found here. So we have 8 degrees of freedom, 2.5% in either tail. And so we need to look this up in the calculator. Oh, what did I do? No, this is 8, and this is 0.025. And over here, so of course we're going to do that by looking for INVT And we need to know the area and the degrees of freedom. So if you look at the lower tail, the left, the area below it is 0.025. And you'll see that it's negative 2.306. So there's two of them, of course. One is positive, one is negative. And that's our rejection region. So yeah, I guess the correct answer to this question is plus and minus 2.306. Um, is there a significant relationship between sales and profits? All right. Well, that depends on whether so in other words, what it's basically saying is test the hypothesis that beta 1 equals 0 against the alternative that it does not. And again, the best way to do that is to look at the p-value, which is found right here, 6.952. Look at that. What's it supposed to mean? Well, it is scientific notation, and it means it's obviously below alpha. So therefore, we reject the null, accept the alternative, that beta 1 is not 0. And that means that, yes, there is a significant relationship between sales and profits. So the answer is yes. And that's the reason why. Now, for the degrees of freedom, sorry, um, go back and look at the chart. I think those got blanked out. Yeah, tone is always one. Um, it's just because it's simple regression. And then for the residual, it's n minus 2, which is 8. The total will therefore be n minus 1, which is 9. I think it wants the actual numbers. Now, the MSR MSE can be obtained like by doing this. So the first one is about 5.92, and the second one is, oh, that's a small number, 0.448987275 divided by 8 is approximately 0.056. So 592 and 0.056. Now, the F statistic is simply the ratio of those two. Get these out of here. Whatever that ratio is what we're looking for. It's about 105, which sounds awfully high, but not for the F distribution. Okay, now coefficient of determination. SSR over SST. If normally it would be listed here, but it got blanked out. So SSR over SST, 592 over point 44898. Okay. It's about 13 point. Oh no, something's not right. Oh, I'm sorry. I did the wrong thing. That's SSE there. I need the total. No wonder it's not right. Yeah, I need the total. So SST is the sum of these two. All right, so here's what I'm going to do. Hold on. So the sum of these two, 6.36, 898. So that means when I come up here, it's about 0.9266. Okay. And then the correlation, well, we know that B1 is positive. Okay. So I just need to take the square root, and it's approximately 0.9626. which might be on that printout. Normally it is, of course, but in this artificial case, nah, it got taken out. No, no, there it is. It's right there. Yeah, no, that's not the right one. Sorry. That's not, it would have been up here. So it is missing. Yeah, it's not that one. All right. So, yeah, that was a little fun exercise, but you're not going to be asked to do this um, on the actual TAP exam. But still, it's helpful giving us insights into some of these concepts. All right, now the last question is a quick ANOVA. Now remember, this you can do in your calculator by entering these numbers into lists. So let's start there. All right, so go to your lists, erase whatever's there now. And you notice for this one, they don't all necessarily have to have the same number of elements. All right, then you go to stat tests. And you want, I think it's the very last one. Yeah, H is ANOVA. And just now keep in mind, remember, this is the one that doesn't have a fixed number of lists. So it'll sit there staring at you, and you have to remember to enter these yourself. All right, so you type second one, comma, second two, comma, second three, and then it'll give you your results. And there's a whole string of numbers here, but let's see what they actually want to know. All right, so the null is that they're all equal. Alternative is that they're not all equal. That statistic is on the very top. That's the F that you see there on the top of that printout. It's approximately 1.322. And your p-value is actually directly below it, 0.309. Yeah, 309. Now, do the pains less than equal number of years. So p-value is greater than alpha, which means do not reject the null if they're all equal. Here, this question is yes. Okay. So that means there's no differences between the paints. They all last more or less the same. Okay. So it looks like that was the last question. Oh my God. So now you're experts in regression and ANOVA. You should have no trouble with the actual final exam. So I'm going to, of course, as usual, post this video on YouTube, and the solutions here will go into Blackboard. And then you'll have everything you need to get through the rest of the exams and whatever the uh, the last assignment would be chapter 14, which is coming up this Sunday. So you have plenty of time to get it done. And again, there's help available if you need it. But if not, well, I hope you had a good time this semester. It's very strange to do it this way. I know that. It's a very unusual experience, but at least you learned what you needed to learn. And I have no idea what you look like, but if you see me walking around the campus, you can feel free to come up to me and say, "Hey, you know what? I was in your summer class." That would be okay. All right, I'm okay with that. So if there's no questions or anything, any last minute concerns, I guess we can stop it right here. And like I said, I'll post everything tonight, and then you'll be all set. Just make sure everything gets done by the assignment by the second and the exams by the third, and you're all set. Okay. So that's it. Who
Thank
knows
you
when
so
I'll see you
much.
again. You're
Have a great
welcome.
summer.
You too. Nope, we're done. That's it. That's it.
Thank
We're
you.
done. All right, bye.
Bye.
Could I ask you a quick question after
Yes.
everyone leaves?
Yes. Welcome, everyone. I hope I'm glad you did that. It's what a strange way to have a class, but we did it. We pulled it off.
I mean, I guess I can ask it while people are still
All right.
leaving.
Sure.
So I've been very preoccupied as on top of this, I've been working in the city and I'm also taking the SIE on Friday.
Yes.
Um, and I'm really like behind with the Excel spreadsheet stuff. Like I'm confused on what I'm supposed to do to complete them.
Oh, all right.
Real quick.
Yeah, there were 4 or 5 or 6 maybe Excel spreadsheets. I've forgotten already, but um, then how many did you do?
I emailed you a couple weeks ago, and you told me that I could submit them at any point because of
Yes,
my
you can.
situation with all the
Yeah.
stuff I was doing. But no, I have not done any yet. I've done all of the Ken gauge work up until this point,
Okay, that's good.
but
Yeah, the Excel is only about 10% of your grades, so don't let that prevent you from doing everything else. But what you can do is if you send me an email, so I have a copy of it somewhere, I'll look up the exact number of spreadsheets that we did. And what you'll find is that if you go through the videos from those nights, um, I mean, we just went right over it. I mean, I just told everyone what needs to be done. Um, so I don't know how long that would take to find the right recordings for each spreadsheet, but it doesn't take that long because we went through it together. It's just
okay,
that
so just fine. So I send you an email, and then you said you'll send me
I'll
the
see what I can do.
six
I'll try to
spreadsheets.
narrow it down for you. What I'll do is I'll
Okay,
say, for example, let's say there's 6 of them, and I'll say, we went over this during this recording, this recording, this recording, and this one. And then just go in there and find it and just watch it and
yeah,
then just follow along.
okay,
All right.
sounds good.
That's all you really have to do.
Yeah, okay. I'll send you the email over right now. Thank you very
Yeah,
much.
yeah. And tomorrow, during the day, I always look at all my emails and I'll start working on it. And in the meantime, you could, if you wanted to, start taking them out. If you look, they're all in Blackboard. I mean, they're all just sitting there. Um, well, actually, you know what? All right, yeah, they're all there. You should be able to find them. So send me the email and we'll get this fixed.
Sounds good. Thank you so much.
Okay, you're welcome. All right, anyone else? Okay, that's it. I guess the thing is, I don't do anything else at Fordham except stats 1 and 2, so I guess I'm not going to run into you again. Unless you find me and tell me who you are. But other than that, I guess this is it. So, okay. Good night.
Thank you.
All right, bye.